Hi, welcome to Bookie. Today we will unlock the book Astrophysics for People in a Hurry. The cosmos is all that is, or ever was, or ever will be. Come with me. A generation ago, the astronomer Carl Sagan stood here and launched hundreds of millions of us on a great adventure, the exploration of the universe revealed by science. It's time to get going again. This is the opening of the popular science documentary Cosmos, a Spacetime Odyssey. It is an updated follow-up to the epic 1980 television series Cosmos, a personal voyage, presented by Carl Sagan. Both of these documentaries reveal the majesty of the universe through a deeply scientific but still relatable narrative, taking viewers on a journey through the largest and smallest aspects of our universe. Every one of us has looked up at the night sky and wondered about the nature of stars. At some point, we've all pondered the origin of the universe, thought about the insignificance of humanity, and tried to contemplate what might be going on in the cosmos. It's human to wonder about the world we inhabit, though few of us go on to study these questions professionally. Life sidetracks us, and before you know it, we become more concerned over car payments and grocery bills than the inner workings of the universe. But that curiosity is still there. Inside every jaded adult is a child still questioning those twinkling lights in the sky. This book provides a direct connection to that inner child by giving us a concise but meaningful way to understand the universe. If you're ready to set off on a journey to the stars, Astrophysics for People in a Hurry is waiting for you. The book was written by astrophysicist Neil deGrasse Tyson, the host of the science documentary Cosmos, a Spacetime Odyssey. It was not only the winner of Amazon's 2017 Book of the Year in Science but also #1 on the New York Times nonfiction bestseller list. In the same year, it topped the readers' poll on Goodreads. This book will take us on a winding path through the universe. Tyson will use simple terms to answer the most profound and deeply rooted questions in your mind. As Tyson says in the opening of the documentary, we are about to begin a journey that will take us from the infinitesimal to the infinite, from the dawn of time to the distant future. We'll explore galaxies and suns and worlds, surf the gravity waves of spacetime, encounter beings that live in fire and ice, explore the planets of stars that never die, discover atoms as massive as suns and universes smaller than atoms. Cosmos is also a story about us. It's the saga of how wandering bands of hunters and gatherers found their way to the stars, one adventure with many heroes. To make this journey, we'll need imagination. But imagination alone is not enough, because the reality of nature is far more wondrous than anything we can imagine. This adventure is made possible by generations of searchers strictly adhering to a simple set of rules: test ideas by experiment and observation, build on those ideas that pass the test, reject the ones that fail, follow the evidence wherever it leads, and question everything. Accept these terms, and the cosmos is yours. Now come with me. Our journey will be divided into 3 parts. Part 1, the birth of the universe. Part 2, the miracle of the starry sky. And Part 3, our wonderful world. Part 1, the birth of the universe. The birth of the universe is arguably the greatest story of all time. Nearly 14 billion years ago, all the space, matter, and energy in the known universe were still contained at an infinitesimal point called a singularity. But what does that mean? Well, a singularity has infinite curvature in spacetime, an infinitely small volume, an infinite density, and infinite gravity. All these infinites are difficult for the human brain to imagine, so simply put, a singularity is even smaller than 1/1,000,000th of the size of the period at the end of this sentence. Don't worry too much about imagining the singularity, even scientists haven't come up with a good description of it yet. We do not know how the singularity came into existence, nor do we know what it really was. None of the current laws of physics are applicable when describing the singularity. Today we use Einstein's general relativity to describe the very big, planets, solar systems, galaxies, while we use quantum mechanics to describe the very small, atoms,